have you ever heard the idea of indistinguishability? Well, it stands for the statistical mechanics of physics. Suppose you are having one object with another. Maybe they looks like identical, but maybe they are not indistinguishable. Confusing, right? Well, let me break down for you right now. Okay, there should be two approaches, the classical statistical mechanics and the quantum statistical mechanics. So classically, suppose you are having two identical particles in a box which have four corners. Right now, if that particle 1 which you know because you are doing the experiment and the particle 2, they are just projected towards each other and somehow at the distance they are colliding on each other. And after that, if they just got back to this corner, so as you know, that particle 1 moved to green to blue corner, where the particle 2 moves from yellow to red corner. So that is what you actually can identify because you are watching that experiment. But what if someone just visit before experiment while he saws that two particles are here, and after this experiment he saws that again two particles are here also. So is that make sense? So according to him, is this possible to distinguish which one particle 1 and which one 2 right now? Completely wrong. He can't. But you can, cause you are completely following this classically in this entire experiment. So that is distinguishable for you but indistinguishable for that person. But wait, let me crack this one for the quantum statistical mechanics. As we know, for the quantum statistical mechanics, there are all the particles in waveform thanks to de Broglie, obviously. So if two identical waves superimpose on each other, so maybe this one is 1 and this one is 2, but make sure after superimposition you can't identify which one is what, right? Even after superimposition, if they just move back from one to another, you still can't identify, doesn't matter how much you are observing this total experiment clearly. So that is the difference between the classical statistical mechanics and the quantum statistical mechanics to identify the particle. For the identical particle, where for classical mechanics it is indistinguishable and distinguishable for the same time, but for quantum mechanics it's always indistinguishable. And that is how the word came as indistinguishable. This word shows the whole story of the statistical mechanics in physics.